Alright, so now that we're ready to go, let's roll. So hold for the inside, so I'm blocking a little bit. So first one is f of 3. So remember, typical, I think I've mentioned earlier that functions is just some fancy way of saying substitution, right? So f of 3 is just asking to what? Substitute 3 into f, and whichever one the output is. And g of anything will be the same thing, but for that function g. So what does f say to do? I'm going to do purple, right? Let's keep going. So it's going to be f says to what? 2 times 3, and then subtract 3. So it's going to be 2 by 3, and then subtract 3 from that. Right? This 3 being the same input value here.
So f we call 2?
F is 2x minus 3, right? 2 times the input. So x now takes on the value 3. So that is just 6 minus 3. Simply 3, I'm sorry. 3. So f of 3 is 3. Alright? Remember, even with these relations, we could write relations as an ordered pair. So I'm going to start with this. So if we want to write this solution as an ordered pair is always at the coordinate. X first, then y. So then this will be 3 for the x with the output of 3, which is could be a point on a graph. Okay? So this will be a point on the graph of f of x. Easy. Alright, so let's move on to the second one. That is g of negative 2. So g of negative 2 is the input now, negative 2 into g. So wherever we see an x, we replace x here. So what does g of x say? Take this input and square it, so negative 2 must be squared, minus 3 times that negative 2, minus 4. All of this is simple time. Negative 2 squared, any number squared is always positive, so that should be positive 4. Negative 3 times negative 2, that's a positive 6. Multiply that and minus 4. So that's 10 minus 4. I just cancel out the 4s, so the only thing left is 6. So g of 2 is, g of negative 2 is 6. Which will give me a point go. What will be the point for this? Negative 2 fits the x and the y value now will be 6. So this will be a point on the function of g. Question?
So you get negative 2, negative 6, I get 3, 3. But all the way, so you get 3. 3 into 6. Oh, so you're done by 2?
No.
You know,
For this one?
Oh!
Still in maths.
Oh, and you get negative 2. Because that's...
It was a question. So let's take now, so instead of g of x, we do g of negative 2. So we're substituting this negative 2 everywhere with x. It's a straight substitution. Alright? Good? So part 3 and part 4 now would be like things that we've done before, which we could look at this as output to input. But again, everybody say that they have not remembered, so please pay attention, please. So part 3 now, it says what? Solve where f of x is pretty much equal to 5. So what is f of x? F of x is 2x minus 3. Set this equal to? And then also the x. So I just transpose the equation. So carry the 3 over, or always add 3 to both sides. So I'm going to have 2x left here. It's going to be 5 plus that 3. That's it. And then I'm going to divide now both sides by that 2. So therefore my x is simply 4. So if I have 4 here, which I put 4 into this function, I will get that 5. Well, if we have the inverse function, we will put the 5 into it, and I still get the 4. That's how it is. Alright? Same thing now. So part 4 says what? Part 4 says where g of x now is equal to 0. So what is g of x? G of x is that quadratic equation. X squared minus 3x minus 4. Now I set that to 0. So this is something that we should all know how to do to solve a quadratic equation. Now, there's quite a few approaches. And I want to look at quite a few. We can use the formula. So we can use the quadratic formula, which you should know it. It will be given on the exam sheet, but you should know it. X equals minus b plus minus the square root of b squared minus 4ac all over 2a. That's a formula. Yes, but this should be on your formula brain.
Yeah.
Imprint it on your brain.
Wow.
Right? So that's one approach. Another approach is to factorize. Right? Using AC method or any of the four methods you know to factorize. In this case, AC method. Thirdly, you could convert, you could do something called computing the square. This is probably the longest of the three. Computing the square, maybe not. Maybe we should look at all three and see. Right? So I'll pause this and then we'll go back into it.